Alright, so in this video we'll be taking a look at ISDN on board on the Sparcstation 10, which in this shot is the machine on the far right, so closest to us. But I thought I'd just really quick give an overview of my Sun collection so far. So we have the SS10 on the far right that we'll see today. In the middle is a Sparcstation 20. Next to it is a growing tower of SCSI. And then to the far left, there's an IPX back there. You can't see it very well, the lunchbox form factor. And then the heavy, Sun CRT. So for me, ISDN has a special place in my heart because in the mid to late 90s, I worked at an ISP and we did a ton of ISDN, just an absolute ton, dial-up, dedicated. And I think one of the reasons we did so much is, and this isn't top secret, I'm in Cincinnati, Ohio, is Cincinnati Bell at the time didn't do metered ISDN. It was flat rate, so it was all you can eat. The base price was higher. I think a 128K BRI was like $110 a month, which was, a lot of money back then. But the good news was it was unlimited. Whereas in other parts of the country, I think most other parts of the country, even if you went just up to date in Ohio, I think the base price would have been lower, like maybe 30 or 40 bucks, but you were billed per minute. So that would really add up. So that's why I think that, one of the many reasons ISDN didn't take off in general, but in Cincinnati, it was a bit of an odd duck. The machine on the right, the Spark 10, has onboard ISDN ports. I just remember seeing that on them and seeing that in the spec sheet and thinking, man, that's so cool, to have this powerful Unix workstation and have ISDN come directly into it. I believe the SGI, the Silicon Graphics Indy, also has onboard ISDN. ISDN, in my opinion, the big benefit was the latency. So I had ISDN at home when I worked at the ISP. It was great. Even with 56K dial-up, if we say, okay, you get 56 kilobit, whereas ISDN is 128 kilobit. So, a little more than double the speed, which is great. But I think the real killer aspect of it was the latency. With dial-up, you'd get, I want to say, in the low hundreds, 100 and some milliseconds of latency. Whereas with ISDN, I think it's in the teens or maybe 20 milliseconds. So about a fifth of the latency. So I'll go through a little bit of an overview of ISDN. I'll try not to go too deep, too much in the weeds. There's plenty of other videos you could watch or read Wikipedia, etc., to get this kind of information. But I thought I'd at least give a quick overview. So ISDN is Integrated Services Digital Network. It is a switched service, so there's still phone numbers and dialing involved as far as phone switches are concerned. You're still using the same numbering plan, you're dialing the same numbers, but instead of an analog voice connection, it's a digital connection, either 56K or 64K. Typically in the US, 64K is the way to go for the channels. So as you can see on the screen here, we have two different pipes, one up top, one below. The one up top is a BRI, that's basic rate interface. That's the 128K service, that's 2-wire. So these arrows don't correspond to wires. The arrows are logical channels. So that top service, the BRI, that's what a small business or someone at home would likely get. And that's 128K. So you have the two 64K B or bearer channels and then a 16K D channel for signaling. So that's your dialing, administrative messages, things like that. Whereas on a POTS and an analog system, your dialing is in-band. So as you dial those tones on the keypad and you hear those tones, the switch is listening to those tones, and that goes through the same medium or channel as your voice, as the actual voice call. In ISDN, that's not the case. It's very nice. It's separate, so it's out-of-band signaling. And BRI is used around the world, not just in the US. At the bottom, though, we do diverge with the PRI. That goes over a T1 carrier in the US or an E1 carrier in Europe, Australia, etc. Also, Japan uses T1. So it's either 1.5 or 2 megabit. And in the US, A PRI is 23 B channels and 1 D channel. And in EU, anywhere that's using an E1 carrier, it's 30 B channels and 1 D channel. And the other difference is you see there at the very, very bottom, that arrow is the same size, the green arrow. The D channel in a PRI is 64K. I guess because you have up to 23 or 30 other channels to keep track of, dialing, connecting, disconnecting. So you need more bandwidth, more administrative overhead, essentially. So that's it. Just wanted to give a quick overview of that. Okay, so these are the ISDN ports on the Sparcstation 10. It's one logical ISDN port and 2 physicals. So the reason there's 2 physicals is here on the left, this port is a U interface. So that's the 2-wire interface directly from the telco. That means there's an integrated NT1, network termination 1. The one that's labeled TE here on the right is the ST, or 4-wire interface. So this would need an external NT1. And like many things, there's differences between the US and the rest of the world. In the US, a U interface was delivered by telcos, a 2-wire interface. And I believe in lots of other parts of the world, the NT1 would be provided by the telco. That would be their DMARC. So the other interesting thing here is you can see there's something in these ports, these black things. These are actually lockout plugs. So let me take one of these out. Basically just take a screwdriver and turn it a quarter turn. And then let's see if we can get this out. Easier said than done. There we go. Let me try to show you this. So it's basically an RJ45. You can kind of see it here head on. There's the screw, not really a screw, but a turn knob. And when it's turned, the clips come down and make this captive in the port. So I would say the reason Sun probably did this is because over to the right, you can't see it in this shot, there is an onboard RJ45 Ethernet port. So they wanted to prevent people from accidentally plugging Ethernet into ISDN, vice versa, causing support calls or causing even electrical damage. So we'll do a quick tour of the Dialup cart. As you can see here, please pardon the mess in the periphery. But there's 3 levels to this cart. 1, 2, 3, 4 devices. So we'll go through those quickly. So we won't be using this device in this video, but I did want to just go over it real quick. It's a BlackBox ALE 224 advanced line emulator. So this is an analog. This is a POTS simulator. And the paper there that you see I've printed out and taped to the top, those are the default phone numbers for each port. So it's pretty simple. It has a really nice VFD display on the front. But you plug phones in and you call them. So I also have some modem stuff going on in this cart. So the main star of the show for this video is right here in front. This, well, they're both red and black, but the one on the right, Teltone ILS 1000 ISDN simulator. And it's a 2-port device. It has 4 physical ports though. So it has both ST and U. And if you look there, you can see I have a black cable on ST on the left for port 1 and a yellow cable for ST on the right for port 2. So I'm using ST ports through and through. And just like the BlackBox POT simulator, I also have the SPIDs, service profile identifiers, and phone numbers printed out and taped to the top. At the left, you probably see what that is. That's a USR courier modem that's connected down to that BlackBox POT simulator for actual dial-up async modem fun. And for our actual service provider, so to speak, I just have an old Cisco 1700 series router. I think it's a 1721, and I'll get a shot of the back here in a second. But this has both ISDN and an analog modem in it, and then obviously Ethernet out to the quote-unquote world. So the real brains of the operation at layer 3 in terms of routing an IP is right there, is this old Cisco 1700. So the back of the router, 3 ports, got Ethernet there in the middle. On the left, the yellow, that's our ISDN. It's a WIC 1B ST, so ISDN BRI, basic rate interface, ST interface. And then on the right, we have our WIC 1AM, 1 analog modem. Okay, so let's take a look at the router config. So all the passwords in here, it's nothing top secret. It's either Cisco or Dialup. This is just internal. This is just a lab, so we don't really care about security. So this right here, this global username, Dialup, the password is also Dialup. This is the account that our end system, so the Sparcstation 10, will use to dial in. So this is the equivalent of, back in the day, your ISP username and password that you'd put in dial-up networking on Windows or whatever that is. That right there is what's going to authenticate that. Our BRI interface, this is our physical interface. This is our ISDN. A couple things in here that are important. We have to tell it what kind of switch type we have. And we're using basic NI, and that's what the Teltone uses. So that's basic national ISDN 1. That's just the protocol. That's basically the flavor of ISDN that it speaks. There's AT&T 5ESS. There's several for Europe, Japan, things like that. So it's basically just one of those things that it needs to match what your telco has. These are also very important. And this is where some of the complexity of ISDN comes in, are the SPIDs, service profile identifiers. We have 2 of those because we have 2 B channels. So this right here, these 2 guys, these are our phone numbers on our side. These are our local phone numbers if someone wanted to call us. And then this is the actual SPID part. And as you can see, it's nothing too fancy. It's the phone number with a 0 at the beginning and a 01 at the end. And that's pretty common. But this is very important. These have to match what the telco has assigned. So when this BRI interface comes up, it essentially negotiates. It has a conversation with the ISDN switch, says, hey, I think I'm these. And hopefully the ISDN switch agrees, says, yep, you're those. And it's essentially a handshake. And then the ISDN comes up at that layer and you're ready to make and receive calls. Fast Ethernet, nothing fancy. It's just a static IP on my local LAN. Async 1, this is tied in. This is the logical interface that's tied into the analog modem. Not going to talk a lot about that. Maybe do another video on the analog dial-up part. Dialer 1, this is what's tied into the ISDN. So this dialer pool 1 right there you see in the middle, this is what's tying it to that. Let me see if I can scroll up. Dialer pool member 1, dialer pool 1. So that's what ties these together. So this is the logical interface to ISDN. I'm using, what is that, RFC 6598, just some /30s on here, nothing fancy. We're doing CHAP for authentication. So challenge, handshake, authentication protocol. Call-in means we only authenticate on incoming calls. And then finally we have this PPP multi-link. So that's what lets us do a 128K connection. Basically the Sun is going to make 2 64K calls. It's going to make a call, get logged in, make another call, and then say, hey, I want to bond these. And then that's where multi-link kicks in. I've got a default route and some other, this is the physical, this line 1 is the physical modem. So we tell it a speed, flow control, things like that. And then just some other bits that come with iOS. Very important thing before you get too excited and get ahead of yourself with ISDN is show ISDN status. And we are actually not looking good. So what we're seeing here, where the problem is this layer 2 status. where it says establish awaiting TEI. That's terminal endpoint identifier, and we have 2 of those because we have 2 B channels. And that's just a unique ID per channel that's negotiated between a terminal and endpoint and the switch. So we're not even getting that far. And I know what it is. It's the Teltone simulator. It tends to do this. It needs rebooted. So I am going to go do that. I will be right back. All right, I'm back. I've rebooted the Teltone. Another thing I did, and I didn't capture this in the original video, but I scrolled back a little bit, is right here, I went into BRI0 and I just did a shut, no shut, which essentially resets the controller. And now we are looking better. This is what we want to see. We want to see right here, these 2 TEIs, 64 and 65. This is nothing that has to be configured. You don't necessarily have to remember it. It's only if you're doing some really deep troubleshooting. These are assigned by the switch, I believe, and they're negotiated. And it's just a unique number to identify endpoints on this particular ISDN link. This multiple frame establish, you definitely want to see that. And then down here for our SPIDs, SPID sent, SPID valid, so we didn't typo those or screw those up. So we are ready to receive calls now. Okay, so we'll finally take a look at the actual software from Sun for ISDN. And apologies, we have a bit of an awkward setup here, so I have to turn my head. Not that my audio is great to begin with, but if you hear the audio sort of change in pitch, that's why I'm kind of swiveling around in my chair. But the first thing is, let's see here. So I've already extracted the Sun ISDN 104, and that's up on Internet Archive. I put it up there. I'll put a link in the description down below. But in this directory, we have patches and product, which is what we really care about. I'm doing this on Solaris 9. From what I could see from this version of SunISDN, it kind of looks like Solaris 7 is maybe when the software came out. And I've tried it on 7 and it works, but I'm trying it on 9 for whatever reason. And it does work. So in the product directory, to get this installed, you have all these Sun package names. So anyone that's familiar with Solaris is going to recognize the Sun W and then the package name. So I've already installed this, but I'll show you kind of what it looks like and what you do. So you do a package add -d dot for current directory, and it will pick all these up and detect all these. So if we wanted to install these again, we would just say all, and we would let it do its thing, and you just go through until it installs them all. And then you really want to do a reboot. There's some daemons that it installs and needs to start. Another thing I want to talk about is default routes and how routing is going to work. So Solaris, of course, pretty old operating system, especially something like Solaris 9. Nowadays in Windows, Mac, and Linux, we have Wi-Fi and we have wired, especially in enterprise or corporate environments. So if your machine's in a docking station, you want to use that wired, right? That gigabit, most likely. So modern operating systems are pretty good about understanding that and deprioritizing Wi-Fi. Even though Wi-Fi is still up, we're still authenticated, it'll basically take those routes and make them a lesser priority or a higher metric, however you want to look at it. Solaris, as you can imagine, being as old as it is, doesn't have that kind of intelligence. So one of the things I needed to do here to not have conflicts, because this machine is typically on my home LAN, is I needed to basically knock it down to a standalone node, essentially. So let me show you kind of what I've done. Try to show you. So in hosts, as you can see, I have the normal IP of this guy commented out, and I just added SS10, which is his normal short host name, to the loopback address. I also, default router, I've removed that and I have, let's just go into Etsy. You know what, let me just run bash. Is it host name? Yeah, so my host name, HME1, which is my normal Happy Meal Ethernet that I use, I've just renamed those to disabled. So what that results in is we don't have our Ethernet. Let me clear this screen. We got a bunch of garbage on there. Make this bigger. So now you can see we have loopback and we have PPP0, and those are the IPs. So this is essentially an island, right? It's not on any kind of home LAN or anything like that. We only want it to get its routes from PPP or from ISDN. So we have it installed, we've rebooted, we've made this thing kind of a standalone node. All of the fun is in opt Sun ISDN. So let me walk you through some of this. So in the bin directory, these are the low-level binaries that it uses for system purposes. Some of the daemons, you can see ISPPPD. So it installs its own PPPD that's tied into ISDN and built for multi-link and things like that. Samples, there's some sample config files, a bunch of include. So if you're trying to write software to use the ISDN subsystem, here's all your header files, some libraries, help files, and tools is really where we're going to focus most of our attention. Specifically, this guy right here, ISDN tool. And a lot of these files are just to support him. Lots of TCL files, bitmaps, things like that. So Sun wants you to put this in your path. I'm being extremely lazy. I'm logged in as root. I'm running as root right now just because of permissions and trying to mess with this stuff. And I'm just going to run it by hand. So nothing fancy. Opt Sun ISDN tools ISDN tool. So this is what we get. We start to get this little GUI menu. So a couple things we want to look at first is our ISDN even up? Remember from the Cisco, we wanted to see those TEIs established. We wanted to see multiple frame established. We kind of want to see the same thing here, right? There's no point in continuing to go forward if our ISDN itself isn't even up. So we want to look at ISDN D channel trace. And this is, as you can see, it's a dev. It's a trace. And that is good. So we're sending and receiving. And if you remember, our Cisco got 64 and 65 for TEIs. So huge surprise. We got 66 and 67. So that means our ISDN is up. So that's a good thing. The configuration, I've already configured this. One thing I've found is that sometimes if the config gets a little wonky, you can stop all this and remove the config files and let this regenerate them. But let me show you what this looks like. So again, there's two layers. There's ISDN, which you have to get your house in order there first before you even bother with PPP. So let's look at ISDN. So NI2, that's the switch type. I had to tell it profile B, which means that we have two channels. So here's our phone numbers, and here's our SPIDs. And that's really all there is to configuring the ISDN on this. So very similar to the Cisco, the switch type, the phone numbers, and the SPIDs. So there's really nothing to do in there. There's a lot more to do in PPP. So this is where we've told it, and I'm using static IPs. I'm gonna double click on this. Yeah, here we go. So Dialup Lab is the name of the remote system. This is our IP, this is their IP, this is the net mask, default route. static, we do want to do multi-point or multi-link. So we have that on. I have this bandwidth controller on, and I'm going to show you that here in a second. But basically, we want it to dial up as soon as we get some activity. You know, we're not paying for this. We don't care. We want it to go. Security. This is our username and password. So it's chat. We do not authenticate them. We only authenticate outbound. Dial-up, just like I said. Phone numbers. So you have to configure these and tell it the interface. We're making 64K data calls, not 56K. We need to dial twice. So our phone numbers end in 2 and 4. And you see 2 is pinned to profile A. And 4 is pinned to profile B. So it will make those 2 calls. And this is where the bandwidth controller comes in. I have the high water threshold set to 1%. So as soon as we send any kind of packets, it's going to try to dial and try to connect. One thing that really screwed me up when I was first playing with this is this right here, this LCP endpoint. It was trying to use Ethernet, and things just weren't matching up. The MAC address, just things didn't line up. So I told it local, and I put in my host ID right here. And this is just an identifier for LCP, Link Control Protocol, to work. I'm trying to think. I don't think I did a whole lot else in here. Routing. This is where that static default route is going to come in, so it's going to push everything out ISDN. So this start and stop, this is to start and stop the daemons, basically the subsystem. And they're running now, so we don't need to really mess with that. We can, though, look at the PPP ISDN log. And it looks like it was connected, but it hung up. So let's try to generate some traffic. So there it went. So quad 8 is alive, and to 8662 connected. So I think we need to send some more traffic to get it to dial that second. So right now you can see it only has one connection. It only has one call outbound, so 64K. So let's think about this. Let's try to get into our ISP. So there we sent some more data, and that triggered the second call. If you were watching here in this window, we have a call on B1 and we have a call on B2, and we saw some activity back here. So now we have a bundle. So now you can see on the ISP side, we have 2 active layer 3 calls. So that's really it. You know, most of the action happens in this ISDN tool, and all this thing is a GUI to write out the config file. I'm sure if you wanted to edit the config file by hand, once you understood the syntax, you could, but the GUI definitely makes it easier. And this is a daemon that runs. It's not like, you don't really hit a dial button like you would if, you know, back in the Windows 95 and 98 days. It's really a daemon that works on demand. So that's why I set that threshold down to 1% to try to get this to not only dial, but then to dial the second connection pretty much immediately. So we're up, we're connected via ISDN, multi-link, we're logged in. Well, we have access to our ISP because we are them. So we jumped on there, generated some more traffic, and that's really about it. I mean, this is working. So Solaris 9 supports IPv6. However, this software is of such a vintage that I'm pretty sure it doesn't. So I did have some IPv6 stuff configured for the analog modem. I was doing that in NetBSD though. So, you know, that's another point to bring up, is that to get the ISDN working and usable on this, it has to be in Solaris. It has to be this software. NetBSD, OpenBSD, anything like that isn't going to support the ISDN controller and making calls. So that is why we are in Solaris today. Okay, so that's it for this video. Hopefully you found it somewhat interesting. And I'll leave you with my favorite backronym, derogatory backronym for ISDN. It still does nothing. Obviously born out of some of the frustration that folks had back when ISDN was however much of a heyday it had. And I didn't mention this previously, but not only could configuration be very frustrating, but just even ordering an ISDN line or ISDN service from the telco. We all know how user-friendly telcos are, but ISDN, for whatever reason, just seemed to even take it up another couple notches. So yeah, that's it, and I hope to see you in another one. Take care.